Hi, in this video, I'm going to introduce ping and traceroute. Okay, so ping is a very useful tool for determining whether or not you can communicate with a device. So here on this PC, we're doing a ping to an IP address, actually the IP address of this router. Looks like that this router has been configured with the IP address on this interface of the last host address for that subnet. Okay, yep, there's its default gateway address right there. So ping, what it will do is send an Icmp echo request. Oh, it looks like, yeah, echo request. Here we go, green. And if it can reach if the device receives it, it will return an Icmp echo reply. And then what we'll see in upcoming screens here is that that reply will be shown. Depending on the operating system, when you use the ping command, it might send 4, 5, 6 of these echo requests, or might just keep on sending them until you hit the break key. But this is a great way to determine whether or not you can communicate with a device either on your own network or on another network. So let's take a look here of using ping to send an Icmp echo request message to a device on another network. So let's say this device here, 10001, wants to see if it can reach this device here. So similar to before, we do a ping 10001 at the command prompt, and that Icmp echo request will be sent and forwarded by the router, here we go, to the device that's being sent to. Oh, I got there should be a 1. There we go. 10011, there we go. It'd be pinging itself, wouldn't it? Okay, and this device here will send back an Icmp echo reply. Now, I want to mention something here because doing a ping and sending the echo request and doesn't necessarily mean, if you don't get an echo reply back, doesn't necessarily mean that you can't reach the device. Why is that? Couple of things you got to be aware of. First of all, you have to make sure that this host's operating system, some of the Windows versions, the firewall will not send out Icmp echo requests. So they'll be blocked before they're even sent. Same thing here. Some operating systems, usually versions of Windows, will not respond to echo replies. So you have to make sure that both ends are sending echo requests and echo replies. Also, it's possible, and it shouldn't happen, but it does happen every so often, that people might configure routers to block either the Icmp echo requests or echo replies. A lot of people think that's for security purposes, but it really doesn't help with security at all. But just be aware that you have to make sure that these echo requests and echo replies are not being blocked anywhere along the way or by the source or destinations themselves. All right, so how can we use the ping command to help troubleshoot connectivity? Well, one thing we can do is ping the remote host that we're using, the domain name. So let's say here I'm on my MacBook Pro, and I'm pinging a domain name. Now, what that tells me, by the way, is gives me an IP address, IPv4 address of google.com. This tells me whether or not I can even reach the DNS server. Okay, let me explain this. Using the domain name, if this was to fail, one problem might be that I can't communicate with my DNS server, meaning I'm using a domain name and there's no device that can give me the IPv4 address in this case. Okay, but let's say this is successful, or then it will show the echo request. Okay, let's say it wasn't successful. The next thing I might want to do is just try pinging the IP address itself of google.com. If this worked, but using the domain name didn't work, that means there's probably a problem with the domain name, me reaching my DNS server. Maybe I have the wrong DNS server address. Maybe there's something wrong with the DNS server itself. All right, but what if I can't ping the domain name, google.com? I can't ping its IP address. Try pinging my default gateway. Can I even get out of my network? So let's say this is the address of my default gateway. Can I even get out of my network? If this works, that means at least I can communicate with my router. Maybe my router doesn't know where this address is. Okay, but at least I can communicate with my router. What if that doesn't work? Hey, can I communicate with other devices on my network? Maybe the router's down. Can I even ping myself? Okay, so I think you get the idea. Ping's a very useful tool for troubleshooting. Okay, so here's using the ping command in IPv6. Okay, this is in on Windows, we can just use the same ping command, just use an IPv6 address. Okay, and sends an echo request, gets an echo reply back. All right. Traceroute. So Traceroute helps us determine what are the routers along the way, along the path from us to the destination. And it uses it actually does a little trick here, at least I'll tell you the way that Windows does it. It sends a ping, okay, using an ICMP echo request. However, in the IP header, an IPv4 header, it will set the time to live as 1, or an IPv6 hop limit at 1. What that means is when the first router receives it, remember what it does with the TTL or hop limit in the IPv4, IPv6 headers? It decrements it by 1. And when it's 0, it will drop that packet and send back an ICMP time exceeded message. Well, now that device knows from the ICMP time exceeded message, it looks at the source IP address of this message, where it came from this interface. It says, now I know the address of the first hop router. So what does it do now? It sets the TTL to 2. So this router gets it, decrements it by 1, forwards it to this router gets it, decrements it by 1, time exceeded message. Okay, now this device here says, okay, I'll just record the source IP address of this time exceeded message. Now I know the second hop. Okay, increases the TTL or hop limit in IPv6 by 1, goes through the same process, gets the next router. Okay, that goes all the way through until it actually is able to ping the end device, and then it says, okay, I know all the routers along the way. Okay. Just as I mentioned, Cisco iOS and Linux do this a slightly differently, but it's kind of the same effect. Okay, here's a traceroute from a Windows machine. So notice that it actually sends out 3 packets, 3 pings inside the IPv6 packet for each TTL. You'll also notice some request timeouts. That's because those routers are not responding. They're not going to send a time exceeded message back. Okay, they don't want to be bothered. Or could be for security reasons, but usually they just don't want to be bothered. All right. So very cool. And it works the same. So it's Traceroute in Windows is the command. All right. In Mac OS, and I'm actually using Traceroute, it's the Traceroute command in Mac OS. And if you want to do it using IPv6, it's Traceroute 6. And here I'm doing a Traceroute 6 to Netflix.com. So I'm going to use ICMPv6 over IPv6. All right. And this is how I get to Netflix, all over IPv6. Okay. So Windows, you can use Traceroute, or if you want to make sure it's over IPv6, you say Traceroute-6. All right. So that's just an introduction to both ping and traceroute.